Alright, so let's see. Do I have anything to finish, or did I finish yesterday?
We finished the.
We finished, okay, because we're awesome. Alright, let's do, okay, it is in your packet. I don't think we've done this yet. It is the third piece of paper, and it says at the top, quiz 6-4 to 6-6, and the first problem, there's 3 pages that all pretty much look alike, but the first problem is change 3, -2 into polar coordinates. That's question number 1. Okay, so it's the third, I think it's the third piece of paper on the front. All right, find it. Here we go. We're going to change this into polar coordinates. All right, so what does that mean? R theta. We got to have R, we got to have theta. How do we always find R and theta? We draw a little picture of it. So over 3 down 2. This is going to require a calculator because that is not a special triangle, right?
You get to use our calculator on the test.
For some things, you have to on this one, right? No choice. So what's my R?
Root 13.
Root 13. And theta is going to be this, right? Be very careful. I keep warning you about that. Theta is the whole big angle, but we're going to find that one first by doing second tangent 2/3, right? So second tangent 2/3, I got 33.69. So what is my actual theta going to be? My actual theta will be 326.31. There we go. Question number 1 done, right? All right, now look at number 2. My gosh, it's exactly the same thing. We're going to change this into polar coordinates. Now I know it's got this little thing over to the side, and we're going to deal with that, but not until we answer the question. Okay? We can't deal with that till we answer the question. So let's change that one. Here we go. Going to need a calculator for this one too, because that is not a special triangle. What's my radius? Root 5. And now I will do second tangent 1/2 to find that angle.
Could you not do 1 over -2?
I never put the negative in. It doesn't really matter. You just have to deal with it. This angle is not negative though, so I'm not going to put the negative in. Now, what is theta? Theta is not 26. It's not -26. What is theta? 153.43. Theta is the angle in standard position that gets us around to the second quadrant. Now, these are the polar coordinates for this point. Unfortunately, the problem, for whatever reason, says, I want you to make R negative. You have to actually make it negative. It will never come out negative. It always comes out positive. If you make it negative, okay, but what does that do to the angle? If you change the sign on your radius, what's it going to do? Move it to the other side of the circle, which is adding or subtracting 180. In this case, I'll add 333.43.
How do you know whether to add or subtract?
We want it to be positive, right? So we'll just add. Okay. So this is step 1. Always, always, always. That is going to be step 1. If you have to change the sign on R, then that is step 2. That's step 2. Okay, number 3. I'm going to write the shorthand notation because I like it better. On the paper here, it's written out in longhand, which is absolutely fine. You can use either one. But it says rewrite in rectangular form. So what does that mean? What am I looking for? X plus yi. That's exactly right. I'm looking for an x and a y. How do I find x and y? X equals r cosine, so x equals 2 cosine 110, and y equals 2 sine 110. 110 is not special, so I don't have a choice. I gotta go to my calculator. So I got negative 0.68 for the x, and 1.88 for the y. Now on the test, somebody might do this. Now is that essentially the right x and y? Well, it is the right x and y. What's the matter with that? Why is that going to lose 1/8 of a point right there? It's not an ordered, or the problem, this guy right here is not an ordered pair. So your answer shouldn't be an ordered pair. This would be the answer if the problem had been 2 comma 110. If the problem had been 2 comma 110, all the math would be exactly the same, right? And our answer would be written as a point. If the problem is a number with an I in it, then your answer has to be a number with an I in it to get full credit. It's the same x and y.
So that's the difference between rectangular and ordered rectangular.
Yep, coordinates are ordered pairs. Coordinates are ordered pairs. So, number 4 is exactly the same problem. You're given an r and you're given a theta, but this time you're given an r and theta as an ordered pair. So what is your answer going to look like? An ordered pair. How are you going to find your x and y? Same way you did here. So what is x going to equal? 4 cosine 170. So negative 3.94. And 4 sine 170. 0.69. And there's your ordered pair. Okay? All right, number 5. Rewrite in polar form. So what are the 4 and the 5? These are x and y. We need r and theta. Am I going to write my answer r comma theta? No, I'm going to write it r cis theta. Same r, same theta, writing it as a number instead of an ordered pair. Okay, so negative 4, 5. What's my radius? Square root of 41. Now I need this angle. So I'll second tangent 5/4 to get this guy right here. .34. So my actual theta here then will be 128.66. That was 5. Number 6. Rewrite as a Cartesian equation. We've talked about these. Gave you a little hint. Anybody remember what I told you maybe? change cosine, and cosine is x over r. Then clear your fraction, because you're always going to have some kind of a fraction. And then what? R squared is x squared plus y squared. Absolutely. You cannot not understand that, people. Right there's your triangle you've drawn a million times. Over up x, or over x up y, there's r. X squared plus y squared is r squared. All right, number 7, rewrite as a polar equation. What does that mean? What do I need to do? Yeah, take out x and replace it with r cosine theta. Take out y and replace it with r sine theta. Take out that x and replace it with r cosine theta. And plus 3. Can you distribute what to this
So
two?
the 2 instead of being r could be 2 cosine theta, or is it always r, 2r cosine theta?
It's always 2r cosine theta. There's no plus in there, so there's no distributive here. You only use distributive when you have an addition. So no, that's just 2r cosine theta. X is r cosine. There are 2 of those. Alright, and last but not least, we've got a couple of complex numbers in polar form. So one is this, and one is this. And we are going to multiply them. What do we get when we multiply them? 15 CIS 250. How do we multiply numbers in polar form? Multiply the r's and add the angles. Okay, now we got a division. Now you got to pay attention to which order you're dividing. So this is z sub 1 over z sub 2. So that will be 3/5 CIS. It'll be negative 90. That will be step 1, because when we divide numbers in polar form, we divide the r's and subtract the angles. So I get negative 90. But we know in polar form we are not allowed to have negative angles. So we'll rewrite that as 270. Okay, what does C mean? That means the conjugate. And when we write the conjugate of a number in polar form, what happens? We keep the r, so this is Z1, so we keep the r. And the angle goes the other direction. But of course we're back to where we were a minute ago. We can't have that negative there, so that will become 280 as our final answer. And what does this mean when you put like the absolute value symbol there? Magnitude. And the magnitude of the number is how long it is when you go out 3. So it's 3 units long. The magnitude of the number is just this r. Okay, now about the only thing not on that is this. So let's do a couple problems that aren't on that, and then I will let you just pick whatever you want to do here. But let's suppose we want to do, and we're gonna do exact. We're gonna answer an exact rectangular form. So anytime you see the word exact, that means no calculator. So I'm gonna answer this one in exact rectangular form, and it's going to be negative root 3 minus I to the 5th power. Alright, so here we go. We're going to answer an exact rectangular form. Okay. Alright. How do I get the answer? Where do I go? What do I need to do here? Change it to polar. So that means over root 3 down 1. Now, no calculator. So that means you better be able to recognize a special angle here. Do you recognize it?
2.
Well, radius is going to be 2 for sure.
And it's going to be 60 across from the...
This angle is 30, because across from the 1 is 30. So your actual angle, though, be careful, is not 30, 210. This is not the answer to the question. That's the thing you're going to raise to the 5th power, right? So how does that work? How do we raise that to the 5th power? 2 to the 5th, which would be 32. 2 to the 5th, radius to the power. And then angle times the power. Right? But that's a tad large, so let's shrink it down. We'll shrink it down by getting rid of revolutions. Does that go down to 330?
Mm-hmm.
So here is my answer in polar form. So if I were allowed to leave my answer in polar form, I'd be done. That's it. But I want exact rectangular form, which means I have to find what? X and Y. And I'm going to do it exactly how I do it on my calculator. If I were allowed to use a calculator, wouldn't I say X equals 32 cosine 330 and Y equals 32 sine 330? Isn't that what I do on my calculator? So everything's the same, except I'm not using a calculator. I'm going to have to figure out the cosine and sine of 330. So I drew 330 degrees. Oh, Miss Ford, you can't expect me to remember that. Yes, I can. We need to remember our 30, 60, 90 triangles. So what's the cosine then? X is going to be 32 times the cosine. What's the cosine of that angle? Root 3 over 2. So that's 16 root 3. Alright, the sine, or excuse me, y is 32 times the sine. The sine is negative 1/2. So that's negative 16. So my answer is X plus YI. That is exact rectangular form. Okay, one more. It wasn't on that sheet. I'm trying to hit everything that's on that sheet. Or not on that sheet. Thinking about the pre-test that we did yesterday. Let's say we have let's find the cube roots let's find the cube roots of 4 root 2 minus 4 root 2i, and let's answer in polar form. Alright, so here we go. How do I do this? I'm finding the cube roots of this number. That means to the 1/3 power. So I'm going to raise this to the 1/3 power. And then, isn't it exactly like that problem then? Well, except I'm going to have 3 answers, but I got to find the first one first, and I'm going to find the first one just like I did over here, right? So what do I need to do? Change it into polar form. So 4 root 2, 4 root 2. Square that, you get 32. 32. 64. 8. How big is that angle right there? 45. Which means your argument is 350. So this is the number that you are raising to the 1/3 power. Alright, so how does that work? 8 to the 1/3, which means what? 8 to the 1/3 means cube root of 8, right? So 8 to the 1/3 is 2. CIS. 313 times 1/3, which would be 105. But you said there were 3 answers, and you were right. No, I don't add 360. I add 360 divided by 3. I add 120, right? If I added 360, aren't I just going to get 3 versions of the same number? Yeah, that's not what I wanted. I'm going to add 120. So, what, 225? Check my arithmetic, is that right?
Yeah.
And there are the polar form answers to the question. If you needed to change those into rectangular form, you could get out your calculator and type x equals 2 cosine 105, y equals 2 sine 105. Get that one. It'd be tedious, but you could do it. And do this one and this one. Alright, one more thing that I can think of that was on the practice or the pre-test. So you're going to have a calculator. You're going to sketch this on your calculator. And then you're going to reproduce it on the grid that I put on the test. So right now, I want you typing that in, and then somebody's going to come up, draw it for us. Okay, so when you're taking your test, I'm not going to be sitting next to you telling you what window to use and all that. No, no, no. You figure it out. Figure it out.
When? Tomorrow.
So we're going to sketch this guy. I need somebody to come up. When you think you got it figured out, I need somebody to come up and put it on the grid. Remember, you can always zoom square if you're not thinking what you're looking at is very symmetric or something. Shouldn't have any jagged edges.
Does it need to be?
Well, yeah, it needs to be the right size, if that's what you mean.
How do you like the second number? How do you know that?
Here she goes. Let's see how she does. I have great confidence.
They were like $3, but there you get like the whole bag on sale.
Okay. Thank you, Peyton, for coming up and doing that. Now, let's talk about, first of all, what shape did she get? Lima sign. And did you know this was going to be a Lima sign? Yes, because of the classical curves, I told you that the only one that had an addition or a subtraction was the Lima sign, right? Now, well, a cardioid is a special kind of Lima sign. This is not a cardioid because these two numbers are not the same, right? Now, so the good thing is she has the right shape. Now, a couple of things here. One thing actually, what she actually drew, it's pretty good. I don't know about this little thing down here, but other than that, it's really not bad. However, there's something missing. What is missing? She changed her scale. And that has to be indicated. This is not 5. What's this down here? This isn't 5. What is it? It's 10. So you changed your scale and need to somehow indicate that on your graph, maybe by marking these like this. Oops. Like this. Like you would on a regular, if you were graphing in a Cartesian and you changed your scale because it wasn't big enough. Also, this little loop here, I think it's a little bit bigger than she has it. What do you think? Yes, so that little loop should actually look like that. So, I expect you, when you reproduce your graph, to have the right shape. Probably not going to count off for this little down here, but that should be. So she's got the right shape, but her size is off a little bit, and that's going to cost points.
How do you know how big to make it?
It should show right there on your graph. It should go down. Well, I don't know how you have your scale set. My scale set of 1, so my loop goes down 2 units. Okay?
Yeah.
All right. What are the 4 classical curves? Rose, Lima sign, which is what we got right here, lemniscate, which is the figure 8, and the spirals. We got 2 kinds of spirals. Ones that start at the center, those are Archimedean, and ones that start out and come in, those are hyperbolic. Their equations are different. If you are hyperbolic, your equation is r equals 3 theta. Oh, no, if you're Archimedean, your r equals 3 theta. Archimedean is r equals 3 theta. Hyperbolic is r equals 3 over theta. Those numbers get smaller as you go around. Okay, I can't think of anything else. So what kind of practice problems do we, or do you need to do? So let me do that. Let me answer all your questions, and then you can have some time to work on your review on your own. If you need to, Katie?
I just have a question about this again. How do we know which way it's like to go? You know what I mean?
You graphed it on your calculator.
So we won't have
You are not freehand sketching this. You are graphing it on your calculator and then putting it on here. what other problem do we need to review together before I let you go? Peyton.
Can we do another one of the like nth roots and
Okay, we're gonna do one more root problem. Like this one right here that I'm just erasing. Alright, so we are gonna find the, let's find, I'm not gonna rig this one. Let's find the, 7th roots of -3 plus 4i. Okay, so I'm totally not rigging it. It's gonna be a mess. Alright, so here we go. I want to find the 7th root. So that would be raising to the 1/7 power, correct?
yes, ma'am.
Patty, we're going to find the 7th root to this. This is fascinating. Now, what do I have to do?
You have to cross.
I have to put it into polar form. So here we go. I know my radius is 5, but I'm going to need a calculator to find my angle, right? Second tangent 4/3, so 53.13. So my actual angle, you gotta get this right, because if you mess this up, everything will be wrong, obviously. So you really need to make sure you get that angle right. 126.87. And that's what you are going to raise to the 1/7 power. Okay, we're going to get 7 answers, right? Alright, so what's the first answer? This is not an answer. You haven't done anything yet. 5 to the 1/7, which you can write as 5 to the 1/7, or the 7th root of 5. CIS.
When do you want the actual number? When it's like a whole number? Or like
Yeah. Okay, now what do I do here? I have to multiply 126.87 times the 7th, or divide it by 7. And I get 18.12. I'm going a little bit around off there in here. There's my first answer. Agreed?
Yes.
Now, there are 7 of them. So here's the first one. And they're all going to have R's that are 7th root of 5. The only thing that's going to be different for all these 7 numbers is the angle. How am I going to find the rest of these angles? I'm going to add whatever 360 divided by 7 is, right? So I'm going to add 51.43. So I have 18.12 plus 1.43. So 69.55. And then how will I find this one? How will I find this one? Add it again. 120.98. 172.41. 223.84. 275. 326.7. And this is so fun. I'm going to go one more. And I came out with 378.13. Now, what about 378.13? Too big, and when I subtract 360, it brings me right back to where I started. I got a little bit of round off error in there, but it brings me right back where I started, right? so I know I got the right answers. There they are. Okay?
When will we have that problem, but not to a fraction?
Well, we did one of those earlier. So if you want to raise a number to a power, so maybe you've got 2 plus 3i, and you're raising it to the 4th power, you're going to do everything exactly the same, only you're only going to have one answer. So we're changing it into polar form, which would be root 13, CIS, my angle. So second tangent 3s, 56.31. So here's my number, and I'm going to raise that to the 4th power. So I take my radius to the power, so that would be root 13 to the 4th, 169. And then I take my angle times my power, and I get 225.24, and that would be it.
Would you not have to, because you only did 4.
Do we have to do both pre-tests or just the one for time?
Okay, here's the deal. I meant for have you do both pre-tests.
Okay.
Is that going to be problematic? I put the in-class thing down, but I made a mistake. I really want you to do both pre-tests because that's what the test is. Like, did we do the in-class review in this class?
No.
Okay, we did it in some class. It's videos. If it's going to be a huge issue, it's okay, but I really think to be best prepared, you need to do the 2 pre-tests.
So try to do both.
Okay, and one of them I know I've done with you.
Yeah, we did the pre-test one.
But what if you've done the in-class review and the pre-test, is that fine?
Yeah.
And not the other pre-test?
Well, I'd rather you did the other pre-test, and I'm going to give you time right now in class to do it, so why don't you get that done? I want both pre-tests, yeah.
Do you want the in-class review?
I don't need that. If you want to do that and turn that in, if you've already done it, that's awesome. It's more practice, it's good practice, but the pre-tests are what the test is like. If you look at the 2 pre-tests, kids, do you notice how similar they are? Okay, why do you think they're so similar? Because they're exact.